Okay. Thank you very much for having me. It's nice to be here. And I saw a lot of you competing yesterday. I saw some of you talking. And I've seen those trophies. And I kind of wish I was competing, because those look awesome. So good luck to those of you who are in the race. As I said, oh, I'm probably in the way. My name is Johan, and I'm a consultant. I've been a tester for, I don't know, some 10, 11, 12 years. I've stopped counting by now. Usually coming from medical technology, and recently, last 4 or 5 years within law enforcement. So it's quite different areas, but both very heavily regulated, and both with quite a lot of documentation. I've also spent some shorter assignments in other places, which may or may not come up. Some short thing about me. That's my history in testing. Some people see this as some kind of graph for load testing or something. I see it as a mountain. I'm a devoted lover of mountains, which you may or may not see in some of these pictures. So this very mountain over here is in Spain. We were running. Village is down there. We were running up here. It's really, really awesome. I can really recommend it. Unfortunately, due to my history and where I work, I will have to wish myself luck, and I will have to lie to you today. That's one of the caveats here. Some of these log files are not ours. Some of them are mocked, some of them are faked, and some of them are honestly stolen from the internet directly. So, as you know, I was allowed to give this speech, and then they changed their mind. So I changed my mind, and I did it anyway. But that's just so you know, for all honesty's sake. And this is pretty much me in one picture. I'm a tester, but what I do is talk. I talk and talk and talk. And that's how we solve most of our problem. Because in my approximation, 75% or more of our problems is not technical. They are people problems. People talk too little to each other or in bad ways. So we don't understand each other, and then we cause problems by building the wrong things. So that's basically me. So today we're talking about the log files, right? And what happens in a log files usually is, where do you use them? How do you use them? Oh, this is, in my experience, from where I come from, a typical case. We have an incident. Something has happened. Perhaps not that serious. When I was in medtech, it could have been, but nowadays it's usually not. But something has happened. Uh-oh, this is not good. We got an incident, a gyro or something, so the team needs to handle it. What do? Well, we don't really know anything. Someone calls and says, this doesn't work, Johan. What do we do? OK, let's go to the log files. Everybody knows this is a log file, right? Matrix style, everything is in there. We all know what to do. We all know how it's going. So basically, we just open it up. We see what happened. We see what should have happened. We find a bug. We correct it. Right? Yeah, not really so easy. So this is what happened for us quite a lot. We got a log file. Sometimes we saw that there is a crash here. Some of the components didn't work. We can't see why. We can't see when. Or we can see when, but we can't see why or how or anything. So the solution, we shove it under the rug. We say, well, this obviously couldn't happen. This obviously can't happen again. So we're not going to spend so much more money into investigating this. And this happens quite a lot. And it's not a really good pattern. So what I think we need to do is, well, first of all, if this is the pattern, have any one of you been in a situation where you've done this? 1, 2, yeah, we got a few. Yeah, that's good. Either you don't have serious incidents or you're not in these groups. But that's good for the rest of you. I've been here quite a lot of times. Yeah, that could be it as well. That could be it as well. So this is usually what we have the log files for. It seems kind of pointless. We have them. They don't help. Something goes wrong anyway. And we can't really do anything about it. But that's not all a log file is. Really isn't. But what is a log file? Well, a log file usually looks something like this. This is actually one of our log files in the background. You can't read it. That's why I kept it. The white one is stolen somewhere. But this is what you get. You get tons and tons of these rows. And for me, a few years ago, when I started, this was kind of gibberish. Now, this is like reading a novel. I love these things. It's so beautiful. You can just see it. Here it is. Who was it? When was it? What did it do? What happened? How long did it take? How big was the file? Why did he get it? Who got it? Everything is here. You just have to read it. And sometimes we get a log file that looks like this. It's a totally different kind of log. The first one is an event log. This is a request log. So we see here, it's up in a Apache server. We can read that eventually. We can see that it's starting up, it's booting, it's everything. The event service, it's registering, it's contacting the other nodes. We can see it's starting. It's working, it's working. We can see that. And this is great. Not when you do it on your own system, but when you do it on someone else's. And that we'll get to that later. And then we have the third kind of log, which is what mine looks like. This is probably my browser log, except that it's the wrong date format. I wouldn't use that. So we have a GET request. We have a long query here for some Dilbert comic. And we can see the beautiful thing here. What was the response? A status code 200. It worked. Success. We got a text HTML file. And we got a time here as well. It took them 1,500 milliseconds to get this comic. Could be good, could be bad, we don't know. Was they doing it on a dial-up? Then it was probably good. Was they doing it on a good cable? No, not so good. But the thing is, there is so much information here. And the beautiful thing is, when you design your own product, this is not it. You can add anything you want. The only basic things that we really urge you to keep is the basics. Who did it? Who's the actor? What's the timestamp? And hopefully, the result. What did you get? As long as you keep those 3 or 4 parts, you can basically add anything, and you can build a lot of information like this. But I'm not talking about testing here. I'm talking about developing. So why should a tester care? Well, I do it because in my picture, this is me following my user. I use the log files for not actually doing any testing sometimes, but just looking at what does the other people do. Because that's what testing is about. Seeing what people do, learning what you do, repeat what you do, and seeing if it will keep working. And even when we add the new stuff. So we follow our users on a beautiful trail here in, this is in northern Spain, I think, on the border to France. Coming up, we got Andorra up to the left there. And there's a lot of things about following the users. As you can see, I'm taking this photo, and none of them sees it. When I'm looking at the log file, none of them knows it. It's kind of a privacy thing. But come on, 2017, privacy, is it a good thing? Is it a bad thing? Is it a big thing? Yes, it is. But we like to just throw all our data out there. I got this from my browser. It was a week ago or something. This is where I live. I did not enter any of this data. I just looked at the log file from my phone. It was an average day. You can see there, home. It knew where I lived. It knew that I went out and threw some disc golfs, because apparently I took a few photos during the day. And I was later in the day, I ran to work, so it got a big red line, because apparently my phone knows if I'm running or taking the subway. It knew that I was at work. It knew I went on the subway across town. And then I got home later in the night. You can see that I had dinner at the restaurant here if you actually follow it through. When I do this presentation, I can do this. Actually, I can go over here. It's quite fun if you haven't done it. Oh, crap. Never mind. Should prepare that part. Yeah. So basically, Google knows all about you. At least if you're signed in, which I always am. And I am that because I know how much I use the log files. And if people can use the log files to track me, to make my experience better, why not? Yeah, I'm naive like that. But what happens when we follow our user? If we track a user, we can take any user. We can take you, or you, or you. Or we can take all of the users. And we take our users, and we parse the log files, not manually. We hopefully have a script for this. And then we throw it back into our model of the systems. Because models is something we tester loves, at least I do. So we take a log file, we parse it back to the model. So we have all our log files over here, and we throw them back into the user module of a system. And what happens is that suddenly we can see everything the user did, how they traverse the system. Did they use it our path? Did they find their own path? Did they find a legal path or not? We can see that. We can also see if there is some paths that are never used when we travel our users. And most importantly, we can see if it looks like this. This is what my test cases used to look like. There's a lot of them, and they do exactly the same thing, all of them. This is photo series from Spain, I think. We were out picking oranges over there, and then we ran back. My friend took about 20 photos on a series. It's really nice. But this isn't really like a good test case. If it works for the first runner, it will probably work for all of them. But this is usually how we build our test suites. We may change something, but all of the most is the same. Which is kind of sad, in my opinion, because we have all this data. We just need to parse it. Especially if we do load testing. So, you see the world as you are, right? This is my version of a bias. The picture is stolen, of course, because, hey, that's what this presentation is all about. So, yeah, now you get time to read. Yeah, I started to hear some giggling, so I think we're done. Yeah, this part is, do they actually use it? That's one of the main questions, right? We get a request to our team. They say, the product owner comes and say, I want the submit button to be yellow instead of green because I want that. That's good. We should do that. Highest on the priority list, up there. And what happens? Well, we can make it yellow or green or blue or whatever you want. And that's fine. We release it. It's bug-free. So that's good. And then we don't know anything. Does anyone use it? Did it increase sale? Did it decrease sale? We don't know. We don't care, really, usually. So that's why I came into hypothesis-driven development instead. And it's the normal user stories changed slightly. So it's, we believe that the change we want will result in some outcome, perhaps. We want the button to be yellow so that more people will continue with their buy. We will have confidence in this to proceed with this when, and this is the important part. What happens if we make the submit button yellow instead of blue or green or whatever it was? We need to have a measurement for this. We need to actually see, did anyone else continue to buy? Did we have a higher or lower drop-off rate? If we have this measurement, great. But how do we have a measurement like that? Oh, I got a solution. We have this great tool, right, that writes everything that the user does. So as long as you have a null hypothesis saying how it was before, we can just add the log file and see, oh, the user that had a yellow button, those were much more likely to click it, or less likely to click it. So suddenly, we have a great tool to see what happens when we do changes. And then it comes the great idea. Great, awesome, this is going to be great. But we might want to take it a bit slow sometimes. It's not always just that the normal hypothesis works as intended. Or sometimes the product owner and the developer have a different idea what something does. So we might want to take it a bit easy. And we want to make sure that we base our decisions on this. Does anyone know what this is? Yeah, it's 2 different cultural references from 2 different generations, or 3 or something, I don't know. To the right, we have the emotions, the feelings, the gut. How do we use to make our decision? How many have been in a situation where you've been in a priority meeting for your backlog, and you based most of your decisions on this? I think that one is more important than that one. Yeah, that makes sense. No, I think this is more important. I've been in those. It's a very common thing. Some companies did very well with this. Apple, for instance, did a lot of that in the beginning. That's what Steve Jobs would do, is something you hear sometimes, because someone has a revolutionary idea. I suggest we go over to this guy, Data from Star Trek. I don't know, really long ago, in my opinion. I'm not really Trekkie. But he's the analytical, cold mind. If the computer says this, then we do that. If the data says that, then we do that. But I don't trust him totally. I want a balance. But I want the balance to shift a lot more towards this side, a lot more over here. And the important thing, as always, the only way we can make this happen is by measuring. We need to make sure that everything my sound is disappearing. Everything we make is measurable. And we measure it through the log files. Because if we measure it through the log files, it's very easy in a web application. We can make it basically anyway. But if you have a distributed application or on param systems, sometimes you will get your log files back, and then you can read it. And if you make alpha-beta testing or flight circles, it's really, really obvious what happens. But what else can we use the log file for? I used to use it in this case as well. This is, I think it's Gran Canaria, perhaps. I was out running one morning when it came a fog, about 12 to 15 kilometers from anywhere of civilization, and I didn't have any water. That's an interesting situation when the fog rolls in. There's a really steep mountain to the left, I realized later. But I love exploring, and I love running out and just seeing what is out there, just as I love exploring in the testing world. And what happens when we explore is that usually we have some kind of system chart again. I love my models. So if this is a simplified version of your system, and you set up your test charter saying, I want to focus on this side. I want to focus on that functionality, perhaps, or that functionality. And you set up and do that, and you have your session. You do all your great routines. You do everything that you used to do. You take your notes. You do your job. And eventually, you say, OK, I feel done. I take a break here. And you open your log file and just see that nothing crashed that you didn't notice. Sometimes it does. It's really interesting. You have a session, you never notice anything, but something has still gone wrong. Log files are great for that. But there are also one more thing they're great for. And that is, again, we parse them back into the model, the same way they do for the user on the web page. We do that for our exploratory session. This is a tool. This is a mock-up of the tool, but we have a tool like this. It puts numbers on all the nodes, or all the edges, actually, saying how many times did you use this function, or this call, or this action during your session from that you said start, or actually from what the log file contains. And then it shows it as well. It paints them red. I never went there. I never went from that system to there. I only went this way. Oh, and over here, I never went there. I never saw these parts in my log. Was it intentional? Perhaps. I mean, my focus was still here. That one probably wasn't intentional. I mean, if I'm testing this exploratory, I really should be using all the ways around it, right? But it's a great way to just see it. And the greatest thing is, it doesn't really cost you anything when you explore. You do your exploratory session just like normal. The only thing you do is at the end, you just add, so how much did my charter cover? And then you have a great tool for it. It helps you. It just tells you, oh, by the way, you might have missed these areas. I'm not saying it's right or wrong. I'm just saying you didn't go there. Ah, beautiful. Now we're back in 2 weeks ago. This is a picture from Stockholm Marathon. We're talking something else here. We're talking a race. I love running. You may notice by now. But this run is slightly different. This time, it's a lot of people. It's a very many people. This is my analogy for performance testing. Because we know these are just normal streets in Stockholm. I know they're runnable. I run on most of them. But it's not really the same thing when you add 60,000 other people. So what did you do? In order to arrange a race like this, for instance, how do you do that? In the good olden times, you had a stopwatch when the people crossed the finish line. Nowadays, for those of you who have run a race or not, you get one of these usually. It's a metal chip. You put it on your shoe, and it will track the time when you cross the starting line and when you cross the finish line. And on bigger races, also a few checkpoints in the way so that your friends at home on the internet can press F5 and see where you are. It's a good sport. Because all of these people, it wouldn't work otherwise. And it's also, if you start in the, like, over here somewhere, far, far, far back, it had probably gone about 10 minutes before you can actually cross the starting line. So that's not a very good result time then. You don't really get a fair chance otherwise. And then you can see it like this. This is actually the winner for this year's Stockholm Marathon, position first. You can see his time. Disgustingly fast, in my opinion. But what happened here was, how did he get all this data? How did the system manage to parse all this data to the user in the browser live for this person and for all the thousands of other people? Well, it's quite a beautiful thing, actually. You make sure that your system logs itself and that it records the beginning and the end of the transactions. In this case, the transactions is user start running, user crosses 5K, user crosses 10K. We get a log post, we get a timestamp for it. And then it's quite easy. So instead of doing it the old way, I manually start my stopwatch, I do my action on my system, I click the button, I wait, I see the light go on, I stop my stopwatch, and I measure the time. That's a fair test to see if the light turns on within 1 second. If I just automate this instead, I make sure that my system itself logs when a user clicks this button. It logs when the light goes on for this particular request. Then we can easily put a script here that says, take that time, subtract that time, and make sure it's bigger or slower than something. And we get the result. It's really not hard. But just by automating this part, you remove it from your test frame. Usually you have like a load tester or a web runner or something that does all these things. It measures the time and it reports the time. I told my system to do that. I told my system to do this. It's part of the system now. Welcome, developers, you do this. Do you realize this? And they say, Johan, that's your job. And I say, no, that's our job. Quality is a mutual thing here. And they say, OK, let's do this. And then it starts spinning off. Because what happens when you've done this? Oh, sorry, wrong picture. What happens when you've done this is that you suddenly have a system that not only tracks itself, you have scripts running on your log files that make sure that, oh, during our test sessions, none of the actions have gone over the maximum limit. Perfect. So I have this script that runs on a log file that makes sure if anything crosses a border with it. Wait. I have much better log files. Instead of using my test log files, I use my production log files. Those are much more production-like and much more realistic. Hey, great idea. So I take the same scripts. I keep running them in production. We get all this data. But in production, we don't want to get there. But we're really interested when we get there. When something starts coming close to the edges. That's when our monitoring system tells us, we need more virtual machines, or we need to buy a new server park, or we need to make sure that our database goes better, because this is starting to get really, really close to our limits. And the thing is, it doesn't cost anything more. Instead of writing exactly the same code in the test frame, we wrote it in the production code. We only had the script outside that ran against the log file. Running against the log file is asynchronous. It doesn't actually perform anything against production. So we don't affect any data. We only extract the information. That's nice. So we have the ID. We have started to gather the information. The system writes it down. We have learned about this. We know we can make decisions on data instead. But that's just me. I got the data. Or my test team got the data. Or my little team got the data. But we have so much data. We don't really know what to do with all the data. We want to make so much with the data. But in order to get forward, we need to push the data here. Push the data into the decision rooms. Make sure that the ones who takes the actual decisions have access to our data. And there is a few ways to do this. You can either write fancy reports with the data and tell them, this is how it is. This report and this graph shows exactly how it was 2 days ago. But that's not a nice way. The nice way is to make sure that they have access to the actual data. Make it easy, make it accessible, make them able to read the data. Because if they can do that, they can make their own PowerPoint charts, they can make their own graphs, and I mean, come on, managers love that. So they really like it. And then they can start making the decision based on it. And what's even better than that, better than having your manager make the decision, is to have the computer make the decision. We want to reach a state where we can trust our computer to make the same decision that you would make in the same situation, given the same data. And that's when our... Okay, so you may have noticed, like, hey, he's not talking about trusting again. Why is he talking about management? Because what happens when we run this log file thingy? We start gathering information. We start sharing information. We're sharing data. And suddenly, we become data-driven, data-aware. We have a sense of data in the company, in the culture, that makes it so that we can actually have this. We can make our system take decisions on its own. We have a few systems like this that runs in production now, that when we push a change directly from our source control, it goes out, it goes live, it monitors itself, and if something starts going yellow or red, it reverts itself, it rolls back to the previous version and informs us. And it's really nice. We don't really need to test that very much anymore, because I know it's safe. Even if I'm away on vacation, it's safe. It will just roll back. So once we can have the data help us not only understand our product, not only rule our product, but actually control our product, that's when we really get there. So how do one get there? I've been talking about this as kind of a story, but I want to give some more hints, perhaps. So this is my friend Katarina. We're planning, again, some mountain. I think this is Slovakia, the Tatras. So not very far from here, actually. The first thing is that set a goal. We learned about this yesterday. If you want to build a space rocket, do that. Preferably a goal that you can finish somewhat on time. Do you all know what this is? Good. Otherwise, go to Barcelona. It's a beautiful building. But then, make sure that you have your priorities straight. Make a wish list. What do you actually want out of this? What is important for your business, your test case? Because in the beginning, remember, you're testers. So the only way you can push this into your organization, probably, is through testing. And it's a really good way, because it's all about data and information. So make sure that you have relevant information that you can gather that's good for you, for your business, for your case. And then you sit there and you realize, okay, so this is what I want, but my product doesn't do that. So that's when we get to these guys. We don't call in Mr. Wolf, but we gather a team. We always work as a team. So this is my developer team. I wish. But you gather them together. You explain what you want to do. You explain this to them. And what happened in my world was, wow, this is great. I'm going to do this. What happened the second time was, meh. So it varies. But you really need support of them. But you don't really need sign up from anyone else. You don't really need to go to the product owner or the manager. Because this, if done right, won't cost you any more money than you would have anyway spent on the other parts. So set a goal, set a plan, cut it down to the very minimum, go together, and then just don't tell anyone. Just do it. Yeah. There is a bit of a caveat here. It's less than 1 year left. I guess you all know about this. Otherwise, it might be interesting to check up. We're getting some new data laws in Europe. And data laws affects companies. And they definitely affect data we store. And what I've been talking about here for the last, sometime, 30 minutes, has been about storing lots and lots of data. So what you want to make sure that if you're going to store data like this and you're going to log it, make sure it's anonymized. You may want to be able to trace it back somehow to the actual user, but it shouldn't be doable for anyone else. Really not. And make sure that you purge your data and that you throw your data away when it's no longer necessary. Because data is kind of like milk. It goes out very fast. Yeah, I hope no one understands, because I don't. But this is what happens usually. Hey, we got data. This is great. So we got so much data now. We're going to do all the great things. But we don't understand it. I have lots and lots of measurements. I have lots of tests, lots of structures, lots of ideas. And I don't get to understand any of it. Because we didn't make it simple. This is all about data for dummies. Unless you're in a serious data scientist or data analyst team, you really want your data to be simple. Don't track things you don't understand. It won't help you. Track the bare minimum, things you do understand, and then expand from that. And if you want to share your data with your management or your co-owner or other team or other companies perhaps, make sure it's really easy and can't be confused, because they will abuse it. And they will make you say, yeah, but you said this and this and this, because they managed to make a graph out of some 5 data points that didn't really relate. And this is a big one as well. After a while, you will get up to the management room, the boardroom, the big guys, where the hippos sit, the highest paid person in the office. And you're going to say like, so we suggest that instead of doing this with gut feeling, you do it with data. Because look, we got this data, we got all those cool monitors done with us. You see it flashing green and blue, and we had graphs and lines and everything. But people don't like to change. It's really, really scary. And they were selected to this management position because they were good at gut feeling, I don't know, or because they wouldn't started a company sometimes. So this is a bit tricky. It's always a people problem, and you really need to be careful about that. Don't just push it on them. And then it's this one. I don't know if you know measurements. These all have the average x, the average y, and the same mean value. But it's not really easy to read the data. It's really not. Just because something looks like something doesn't really mean it is. I can stare at this for a while. I find it really cool. Oh, look, that's that way. That's that way. Oh, ta-da! Yeah, you can really do that for a long time. So what I've been using is mainly home-hacked stuff, but there is a ton and ton and ton of tools to use from. This is my selection for starters, because they're mainly open source. There is, yeah, probably Humio here in the middle is not open source, but you can get a free trial for a month or 2 if you want to try it. It's a really cool product. What most people start with, I think, is usually the Elastic Log/Kibana, also known as the Elk stack. So that might be a good way to get in there, because if you have a lot of different products, they're really good at talking to each other. Otherwise, Hadoop is great for data management. Humio is great for managing data logs. And all the rest is just tons and tons of features I haven't really used. I've used all of these to some extent. But mainly, we've written our own products because we didn't really need all this. And it's open source anyway. So you can just steal the parts you want. But that's basically what we've been doing. And I can't really recommend or not recommend any of these. I just think that if you choose one and keep with it, you'll probably start to like it. If you talk to someone else, they will definitely use something else than you have anyway. So I'll just say just that Google it, try it. It's all easy to start up with. And it's really not that hard. So this is basically what I've been going through today. We talked about different kind of testing, different kind of data, different kind of logging. A lot about running, because Rehate is really fun, right? And we talked about a bit about what happens, why we keep producing things that we don't need, where we've been. So yeah, I think it's been a good journey.